Hey, what's up? Today we're going over merge sort. Now, what merge sort does is we take an unsorted list and we are going to split that list in half and then recursively sort the two halves. So with our left half, we're going to say, all right, we're going to run merge sort on the left half, and then that will cut it up again into quarters and then to eighths. And then until we have lists of essentially size 1, where we're saying, okay, we have two lists of size 1, we're going to now recombine them and output our results. We are basically breaking down our sorting problem into smaller subproblems that we can solve efficiently. The first thing I'm going to do is in our merge sort function, I'm going to have a conditional that checks, is our list empty or is it only 1, in which case we return the list. The next thing we're looking to do is we want to find the middle of the list we're given, and all we're doing is we're taking the length of the list, we're dividing it by 2, we're taking the ceiling of that function, and then we are going to take the left side by accessing everything to the left of the middle, and then the right side by doing the same thing. Next thing I'm looking to do is I want to run merge sort on the left of the list, the right of the list, and then somehow merge them together in their right order and output that as my final output for merge sort. Now the trick here comes into that merge function. For our merge function, we're going to take in the left side and we're going to take in a right side, and now we need to put them together. So before we do that, let's write down a couple important things. We want to know what is the total length of the output list, which will just be the sum of the two input lists. Then we want to track an index for our left list and also track an index for our right list so we know where we are. And then finally, we want to also just declare our output list, and this is what we'll be added to. Now, the next thing we're going to do is we're going to iterate over the length of the output list, and we're going to have a couple cases. So the first thing we want to check is if the left list is empty, and we can check that by saying if the jth index, which we'll be iterating every time we take an element, if that is greater than the length of the left list, then we know we're done. Similarly, we also look at our right list. So if our right list is empty, then that k number is going to be greater than or equal to the length of the right list. Finally, we want to check, assuming that both lists are not empty, is the left element smaller than the right element? If it is, then we'll take that element and we will attach it to our output list. If it's not true, then that means the right element is smaller than the left element, so we'll attach that element instead. And also, going back to our empty cases, if one list is empty, then you should simply append elements from the other list. So while I'm doing testing, I want to briefly go over how merge sort works. Now, when we look at the function, we see that we're merging the left and the right. And the left and the right, before we do that merging, they're going to have called merge sort. So then when we look at the left and the right, they're going to be split in half and they're going to do their thing. And even though we see this merge call at the end of our code, that call is coming at the very end. So we start with, let's say, a stack of plates. We go down to the stack of plates all the way down our recursive calls, and then we sort them as we're coming up. And then our final call at the top of the stack is going to be our merge call for the two halves of the list. And by two halves, I mean the original list.